Hi, and welcome to this special at-home edition of running cost-effective big data workloads on Azure Synapse Analytics and Azure Data Lake Storage. My name is James Baker. Today with me is Michael Rees, and together we're going to show you how to get maximum insight from your data in the most cost-effective manner possible. So let's get started. So today we're going to look at ways in which we can modernize these big data workloads to drive cost efficiencies into them. Then we're going to look specifically at the cost improvements that are associated with the integration between Azure Synapse and Azure Data Lake Storage. Michael's then going to take us through a demo where we're going to show many of the features that we've been speaking about, and then we're going to end up with an exciting announcement around .NET for Apache Spark. So when we look at the way that we've composed BI pipelines over the last sort of 30 or 40 years, this is a pattern that should be very familiar to a lot of you today. We see the operational databases being the source of these pipelines, going through a series of rigorous ETL jobs into an enterprise data warehouse, and then more data movement leading out to scenario-specific data marts and onto their specific consumption layers. Now, this has been a great pattern and has worked well for a long, long time. But what's occurring and what the awareness is that while this is fantastic in analyzing specifically what comes out of these operational databases, things like, what are the sales for each region or things like that, what it's not great at is establishing a lot of causality. So you can't work out exactly why sales might be up or down over a particular month. You can't also do interesting correlations between other data sets, which may give you that insight. And importantly, you can't lead to predictive analytics, which may give you an indication of what happens in the future if you're able to make certain changes. In addition to that, the rigor required to move from structured operational databases into structured enterprise data warehouses via these ETL jobs makes these ETL jobs fairly brittle, fairly prone to failure, and as a consequence, fairly costly to over-engineer and maintain. But generally, we need to go and achieve these same sort of goals, and so we look at what we can do to mitigate some of these challenges. And this introduces what we call the modern data warehouse pattern, where the goals of taking data on the left-hand side, moving it through a processing pipeline, and getting consumption and reporting on the right-hand side are the same. The way we do it, the types of transformations, and even the types of data in the pipeline have varied significantly. And that greatest change is you'll see on the left-hand side. The variety and the volume of that data has changed dramatically. And organizations have realized that the more diverse sets of data that they have feeding into these pipelines, the more insights that they can gain. But a lot of the times that variable quality data is not in a state that can be moved straight into a data warehouse. It doesn't conform to certain fixed structures. And so therefore you need to move it into something like a data lake store, in this case ADLS, in order to be able to have this low barrier to ingest, store the data, enrich it in place with tools that are able to work with that variable quality of data, and then enrich it to the point where it can go into a consumption layer in for serving. And so in addition to that sort of variety of data, the volume of data has also changed dramatically. And again, ADLS is a storage service which is very scalable by design to deal with these vast amounts of data driving through. And so this modern data warehouse pattern has been very successful for a lot of customers running on the platform today. We encourage them to continue to work for this and continue to get more and more insights. For instance, have their data scientists work through this prep and train phase to get more interesting causalities, more interesting correlations that come out of that data and emerge and get ready for the business consumption downstream. But many of the challenges associated with this pattern are that it's really a collection of a variety of tools that we make you put together yourselves. And so one of the ways that we're sort of approaching this is to say, hey, let's have a tool, a single tool that encompasses all of that workspace. And this is what Azure Synapse Analytics is all about. It is the manifestation of the modern data warehouse pattern, and its integration with ADLS really drives a lot of cost efficiencies, a lot of value add in the way that we can achieve those same goals that the MDW pattern has today, but do it at a much more cost-effective, much more performant level of operation, which in turn drives the opportunity for greater insight to be extracted. So if we drill a little bit deeper into what's included in Synapse, we can see that not only is the integration with ADLS very tight here, there's also a shared metadata layer, which also drives that convergence. Then we've got a choice of a variety of runtimes. We've got Spark, we've got 2 forms of SQL in there. Those allow the right tool to be used in different phases of those pipelines, but then it all comes together under a single unified user experience, which really, again, drives extra efficiencies and a really sort of consistent experience. So let's drill a little bit deeper into some of the components that are included in Azure Synapse. In the Spark distribution, for instance, .NET support is included by default, meaning that all of your .NET developers can now become big data developers, leveraging those existing skills in C# and F#, which include some really great functional capabilities, which are very applicable to data manipulation. Hyperspace materialized views allows results to be cached on locally, meaning that similar results can be served directly out of that cache, leading to faster query times. And as we've already stated, faster query times leads to less expensive time on the cluster, cheaper insights. On the SQL side of things, the key takeaway here is that this is a very familiar experience for lots of existing data developers. And so that really saves on retraining and retooling that you might otherwise have to do. On the serverless model, because this is a pay-for-query model, there is no over-provisioning that you can run the risk of. There's no down cluster time or underutilization because you are only paying for the amount of data that's processed on each query. Additionally, because there are no clusters, it's just a pay-for-query service, there's nothing to monitor or manage, which again leads to lower maintenance costs. On the provision model, there's really rich features. The provision model is the existing SQL data warehouse model that we've all know about. And so there's really mature features such as work groups, which maximize utilization whilst providing query isolation. Also, the materialized views and results at cache, similarly to on Spark, provide the ability to serve those results very quickly directly out of cache. And so again, that leads to faster results, cheaper insights. So now let's look at some of how the capabilities in Azure Data Lake Storage specifically help this cost efficiency as well. The disaggregated model that we use when marrying Synapse and ADLS allows both of those resources to be scaled independently, meaning that if I bring on more data, I don't necessarily need to bring on more compute, and vice versa. That leads to maximum or the highest utilization possible in both of those resources, meaning that we're not stranding any particular resource, which is quite different from other analytics models that exist out there. Also, features such as lifecycle management means that data is always being stored in the tier that is appropriate for its life cycle. The tiering allows a trade-off between storage performance and storage and the cost of that storage. And we have policies that intelligently move that data around based on usage or other policy factors that you can enter in there, meaning that you don't have to be touching each of the files to move them into the right tier. The policies are doing that for you automatically. And then, as we've established earlier, the greater the performance, in this case, the performance of Azure Data Lake Storage with its specific capabilities for analytics, I/O patterns, meaning that we've tuned it specifically for those sort of patterns, allows that storage layer to perform much, much faster. That leads to faster queries, which are great, but it also means less compute time, which of course means less cost associated with doing those particular jobs. So now let's look at some of the benefits of integration between Synapse and ADLS and what flows as a consequence of that tight coupling between those two services. Firstly, what we've spoken about earlier is the single management portal. This really does drive down training costs across all of the operational staff, ranging from the administrators to the data scientists, the data engineers, and even the business units, that they only have to become familiar in a single tool. The security, the fact that it flows end to end, means that it only needs to get applied once, and data stewards don't need to incur the costs of continuously having to restate the security in different locations. Similarly, the shared metadata experiences allow those data owners to only have to state the data model around that data once. Integrated workload monitoring means that there's one set of tools to monitor what's going on in the workload system, as well as a single set of diagnosis tools that need to be called into play if incidents need to be investigated. And the final piece is a unique relationship between Synapse and ADLS, a feature that just went generally available called query acceleration. Query acceleration causes elements of the query to be evaluated down in the storage layer, which means that there's subsequent efficiencies associated with not having to move that data back up into the analytics framework. That leads to better performance, and as we've spoken about earlier, better performance equals better cost savings as well. And we'll look into more details than that in a couple of slides. So one of the first things we want to go and drill into is that shared metadata experience that we've spoken about earlier. You know, it's very common, and many of you will be very familiar with writing data definition statements in Spark that define things like tables, databases, columns, petitions, all of those sorts of things. That information is stored in the Hive metastore that's associated with Spark. Everything's normal, as you would expect in a Spark distribution. But in normal circumstances, the data doesn't go any further than that. With this new shared metadata experience in Synapse, however, that data is now able to flow on to the serverless SQL experience. And then if we opt into it as well, into the provisioned SQL experience as well, meaning that all of these definition statements and the data models associated with it flow across all of the experiences that we can have, which means that I can issue very similar queries referencing the same entities in all of these environments that cause great efficiencies associated with it. And what that means from a benefits perspective is that I don't have to run orchestration jobs that copy data out of the Hive metastore and across these other environments, or even worse, manually restating these definitions. Also, I don't have to worry about having to duplicate the data potentially when I move data to different environments to accommodate the different data models that I might have. Another element that we spoke about earlier is the integration between Synapse and ADLS around the new query acceleration feature. Query acceleration allows elements of the query, the query optimizer within Synapse has been enlightened such that it can push certain predicates and column projections down into the storage layer. The storage layer can then evaluate those predicates and projections directly as data is being read off the disk, meaning that superfluous data that is not normally required to satisfy the query no longer needs to flow up through the storage service across the network and then be parsed within Spark. All of that cost is eliminated. That leads to not only significant performance improvements, but as we've heard before, performance improvements equals cost improvements as a consequence. And so this level of integration that we're showing here between Synapse and ADLS is evidence that we really believe this is a new paradigm of analytics, storage, and the frameworks integrating with them to drive better value, greater opportunity of getting insights from the data that you have. So let's now switch to a demo with Michael. He's going to take us through many of the features that we've just spoken about, ranging from .NET for Spark, the shared metadata experience, and the query acceleration integration. Over to you, Mike.
Thanks, James. Hi, everyone. I'm Michael here. I'm going to give you the demo and walking you through the experience of using Azure Synapse and Azure Data Lake Storage together to do your data preparation and data analysis. So let me head over and explain to you how the demonstration will be going. We have a couple of Twitter CSV files that we have stored in Azure Data Lake Storage, and we will be using Azure Synapse to prepare the data and then do some analysis on it. We start out with using the Spark Scala experience to do the data preparation and transform the CSV files into a topics table that contains the information extracted from the tweets, what topics these tweets were about, and another table called mentions where we track who has been mentioned by whom in the tweets. These two tables will be shared as part of the Synapse shared metadata experience, not only with all the Spark notebooks and Spark pools that we have available inside our workspace, but also the integrated SQL experience that we have in Synapse. In particular, I will be showing you using interactive .NET notebook experience in Spark notebooks that we have in Synapse, what I have been up to based on the tweets over the last couple of years. And then I will be using the Synapse SQL experience to also show you who has been interacting with me during that time frame. And of course, you can imagine once we have the SQL experience, you can use your Power BI experience and Power Query to go and operate on that data as well, and basically get access to the whole SQL experience that you have for doing data analysis. So let me now switch over to the demo. What you see here is my Azure Synapse workspace through the Azure Synapse Studio experience. In particular, I've opened the Data Hub to explore my Azure Data Lake Storage account. I navigated to the folder that contains my tweet CSV files. You see a couple of CSV files here. If I right-click on one and preview, you will now see here the 4 columns that the CSV file contains. There's obviously no header file here. You have the column for date, a column for time, who tweeted it, and what the tweet was. Now I'm going to basically process these tweet files using Azure Synapse Spark and also then the process data with Synapse SQL as well. Now, just to show you, if I right-click here, I could go and, for example, create a SQL script directly on the file or a notebook, but I have already prepared some notebooks here and some SQL scripts, so let's take a look at those. Let's first do the data preparation. I have here my data preparation notebook. Obviously, I could also write this as a Scala application using Spark and submit it as a batch job and orchestrate it using our pipeline, orchestration pipeline that we have that is based on Azure Data Factory. But in this case, for demo purposes, I'm using a notebook. And that notebook is also attached to a Spark pool called Spark Data Prep that will give me the resources to run this notebook. When I run my notebook, the first statement here that I'm doing is basically defining my user-defined function that does the extraction of my tweet handles if I use the prefix @ or my tweet topics if I use the prefix hash. As you can see, the command executed in about 48 seconds, which is the time it took to create the Spark pool instance. Obviously, if I would just run it without having to create it, it would run much faster. In the next cell here, I'm reading my data from my Azure Data Lake account. And you will notice that I'm using a wildcard here, and I'm providing the schema and the format that I want to read those files from. Now, if I want to make use of the query acceleration, which is useful if I, for example, only want to select a subset of the data, either a subset of the columns, such as, for example, only the author or only the tweet, or if I want to select a subset of the rows by, for example, having a predicate that can be pushed down into the storage layer, I can rewrite this expression by using a class of Azure Data Source, and then I can provide the name of the object of the class of data source as a format. And at that point in time, basically the optimizer knows that it can push down some of that information, and I can reduce the I/O that I have by having the storage layer do the query acceleration for me. Now, in this case, I'm interested in all the data, and I want to read all the columns, so I'm not using that at this point. But I just wanted to show you how easy it is to basically use that. Now, in the next steps, I will be deduplicating my tweets here to make sure that I only have each tweet counted once, because I have obviously multiple input files. There might be duplication. And if you look at the result here, I actually removed about 185 duplicate rows here. Then I take that function that I created earlier and register two user-defined functions, one that extracts the mentions, one that extracts the topics. I then apply this to my tweet data here. I transform the data frame into a tweet and mentions data frame that contains a bunch of columns with mentions and topics. Now, as I mentioned earlier, I want to have one table each. So I'm creating a mentions data frame here by exploding the array of mentions into one mention per row. The same for topics, where I explode my topics array into one row per topic. And then I go and basically create my tables down here. Now, for the tables, important is to notice that we are sharing at the moment both managed and external tables that are backed by Parquet. So if I use mentions, write, save as table, then the default storage format is going to be Parquet, so that will be shared with our SQL experiences as well, as we saw earlier in the presentation. In this case, I also repartition my data frame into a single partition, primarily because I only have about 30,000 rows in one case and 80,000 rows in the other case. And I don't want to have too many files that are created behind, as packing the table, so I basically repartition it into one file to make sure that my queries will be fast enough. So once I've done that, the tables become available. So if I go over here to my data tab and look at the workspace, you will see here that I have an Ignite tweet analysis database. That is the database that I have created. And inside here, I have the mentions table and the topics table. Now, it says here that this was created by Spark, but I can go and use it with SQL as well, as we will see later in the demo. Now, just to show you now how I can use my .NET experience, I could write the same data preparation notebook using .NET and in particular C#. Now, in this case, just to show you, the notebook actually gives me interactive C# experience using .NET Interactive. So in this case, I just have a standard C# expression, taking a string and splitting it into its components. And again, in this case, it took 49 seconds, so it again kind of created my Spark pool instance in a short time. I can just run it again, and it will probably be much faster to rerun the query here. And you see here, it just gives me a nice interactive way of exploring my C# expressions. But of course, I can do the same what I've done earlier using .NET for Spark as well. So in this case, I'm writing a user-defined function called extract items and register it again as a UDF, very similar to what I've done on the Scala side. And again, I'm creating my tweet data frame by querying the same tweet files, do the deduplication. And again, you see that I removed 185 duplicates here. I will then create my mentions and topics data frame. I go and create my mentions tables, first my data frames and topics data frames, and I create my database. So this looks exactly the same as in the Scala context, except for that I'm using the some .NET specific syntax agreements, like uppercase methods instead of lower camel case methods. And I'm basically running this obviously using a .NET runtime. Now, of course, the actual core expressions that we are having here, like, for example, the Spark SQL expressions here, or in above here, the select and column projections, etc., the explode statement, these are just like Scala, and they will be creating the same execution tree behind the scenes, and it will be executing the exact same code inside the Spark execution engine. The only difference is that I program this in .NET instead of Scala, and I can use .NET user-defined functions, such as my extraction statements here, instead of the Scala user-defined functions. So now I also show you here .NET interactive experience using just Spark SQL to show you some more capabilities that we have with the .NET experience. So in particular, I show you a nice usage of the built-in visualization libraries that the .NET interactive notebook gives us. So in this case, what I do is I use some Spark SQL expressions here to find the top 5 quarterly tweet topics that I have been tweeting about since I started tweeting, and to see kind of like what I have been up to, basically. So this Spark SQL expression here, that I will not go into much more detail, kind of gives me this nice tabular format, which is obviously not very nice to understand what was happening. So let me go and do some cool visualization using the built-in Plotly library that we have. So in this case, what I use is I use my data frame here that I have created. I collect the result and basically bring it into main memory, and I translate it into .NET IEnumerable. And then I use some .NET code to basically build up my column stacked bar chart graph that I want to visualize. In particular, what I do here is I use a bunch of link expressions, both here as cascading expressions or down here as kind of the link SQL-like experience, to process the data in main memory to do my visualization. Now, obviously, these link expressions will be processed in memory. They will not be sent over to my Spark cluster anymore. So the visualization now gives me, let me hide the data tab here, gives me this nice interactive graph experience that is built into the .NET Notebook experience. And it shows me here that I kind of like worked on kind of 3 projects. If you look at the shape here, if you hover over it, you see this was like SQL related. I was working on SQL Server 2012 here about on like beyond relational capabilities, was apparently giving some presentations at SQL Bits and Strata and so on. Then I was working here in 2015 to 18. I was working on Azure Data Lake and USQL. So you can see tweets about these. And then recently I have been tweeting about Azure Synapse and .NET for Spark. So these are the projects that I'm currently working on. So as you can see, you can just look at my tweet data to see what I've been working on. And if I'm not tweeting, then I'm probably working on either something internal or preparing for my next adventure. Now, as you have seen me use Spark to analyze and prepare the data. Now, one thing I want to point out is that the analysis notebook here is actually running against a different Spark pool, but the Spark pools within the workspace share the same metadata, so I was able to see the same table. Now, I can share those tables not only between the different Spark pools, but I can also share it with my SQL experience. So in this case, I have a SQL on-demand interactive query here, where I'm now running against the Ignite tweet analysis mentions table, in this case in the DBO schema, which is kind of our default mapping from Spark, where I look at the at everybody who has tweeted at least 5 times at me to see who has been interacting with me. Now, in this case, I can run the query. So you will see I already did run the query. It took less than a second to execute. The first time I run the query, though, it's going to take a little bit longer because it has to get the resources to run the query from the system. So it should take about 10 seconds for executing the query, plus minus a few seconds. So as you can see, I got the result in 10 seconds. If I rerun the same query again, it should be now taking much less time because I have accumulated the resources that I need in my SQL on-demand experience to run the query. As you can see, it now executed again in less than a second. SQL interactive experience here also gives me a nice way of visualizing the result. In this case, I chose to do a column chart type with the author as the x-axis, so you can see who was interacting with me and how many times each one of these person mentioned me. So with this, I would like to kind of finish the presentation. So you have seen how to use the shared metadata experience to share your processed Parquet back tables between Spark and Synapse SQL Experience. You saw me use the .NET experience for Apache Spark using interactive notebooks. And I also gave you a quick introduction on how to use the query acceleration in Scala Spark experience. With that, let me now switch back to the presentation and conclude the presentation. It is with great pleasure that we are announcing version 1.0 for .NET for Apache Spark at Ignite. Now, .NET for Apache Spark is giving our .NET developers a first-class C# and F# experience to program big data analytics solution with Apache Spark. It gives you the ability to write your programs, as you have seen, and in .NET, as well as use existing .NET code as user-defined functions and use it in the context of Apache Spark to scale it out across your data that you want to process. .NET for Apache Spark version 1.0 will be part of Azure Synapse as soon as it is being released. And it will include support for Apache Spark 2.4 and 3.0 data frames, structured streaming, and Delta Lake. It is based on the .NET Standard 2.0 and will provide you with C# and F# bindings, as well as access to the ML.NET libraries. .NET Standard 2.0 means that you can run it using the .NET Core 3.1 or newer runtime, or you can use it if you have a local Apache Spark installation, also with .NET Framework 4.7 or newer. Furthermore, we have done a lot of work to optimize the performance of the interop between the core Scala execution of the core Spark expressions, as well as the invocation of your .NET user-defined functions. In particular, we have worked with the Apache Arrow team to add .NET support for Apache Arrow and improve the interop communication between .NET and Scala that way. Furthermore, we have provided hardware vectorization support if you support hardware vectorization in your context of Apache Spark. We also provide you, as you have seen, a first-class integration with Azure Synapse, both with batch submission of .NET Apache Spark code, as well as the ability to use interactive .NET notebooks with .NET for Apache Spark. If you want to learn more, please go to .NET/Spark to learn more about this. Note that the .NET for Apache Spark v1 release is not only for Azure Synapse. It works for all the other Spark distributions as well. It just happens to be that Synapse is providing an out-of-the-box experience for that. Now, to conclude our session, let me give you a few further action items to follow up on. Please go and look up all the other sessions that we have around Azure Synapse, including the session that I want to call out here by Ewan Garden on real-time analytics and BI using Azure Synapse Links for Azure Cosmos DB, which not only talks about Azure Synapse Links, but also shows you, for example, other Spark capabilities that we are shipping, such as, for example, the hyperspace materialized indexes that give you the ability to optimize performance further. If you want to learn more about Azure Data Lake Storage, please go to aka.ms/ADLS. If you want to get started with Azure Synapse, please go to aka.ms/Azure Synapse. And if you want to learn more about .NET for Apache Spark, please go to the aforementioned .NET/Spark website to learn more and also get some more demos, etc. Furthermore, if you have existing data warehouses that you want to migrate into the Synapse experience, please leverage the Informatica Microsoft Data Warehouse Migration offer at aka.ms/Synapse Informatica POV, where you can get more information about that. Last but not least, if you want to engage with us directly about the session, please tweet at us at MikeDoesBigData and at BigJamesBigData. If you have specific comments or questions or interactions about this session, please tag your tweet with hashtag OD220. That way we know that this is about this session. With that, I thank you very much for your attention, and I hope to see you soon in Azure Synapse analyzing your data. Thank you.